And there we go. Okay. We already put this on the board, but standard form, just so I can fill it in, is y equals ax squared plus bx plus c. As we just saw on the computer, the a value was the exact same thing it was last time. The a value tells us, is the parabola opening up, down? Is it wide? Is it narrow? All that stuff. The b value was complicated. Right now, I'm just going to say the b value moves the parabola. More details on that later. We're not going to be too specific about that for right now. But the c value we saw was something important. What did we say the c value told us? The y-intercept. The c value gives us our y-intercept. And when I ask you for the y-intercept, I'm going to ask you to give me coordinates. The y-intercept of our parabola is the point 0, c. So you're given a parabola over here, y equals 2x squared plus 3x minus 4. Hands, what are the coordinates, don't just tell me a single number, give me coordinates, of the y-intercept for that parabola? The one that's right over here. Josh. 0, negative 4. It's really just as easy as looking at the formula and picking out the number. So vertex form is really nice because you can look at the formula. We should have our notes up, by the way. Right. Vertex form is really easy because you can look at it and you can know the vertex right away. What's nice about standard form is you can look at this and without any calculations, you know what the coordinates of the y-intercept are going to be. What I would like you to do right now, on the bottom of the page, you have 5 formulas for parabolas. I would like you to use the c value to determine which parabola matches with which formula, which really means we're just using y-intercept ideas. See what you can do. This should not take super long. Robbie, what did you say for 1? D. Good. And Evan, how about 2? C. Good. Byron, how about 3? That would be A. And Megana, how about 4? Yep, that's going to work. So by process of elimination, but also because it is right, E, this one over here, has a y-intercept of 3. Easy enough to match those. By the way, the homework looks like a lot. Well, there are going to be 5 or 6 of those problems just like this. That should take you about 30 seconds. And then 5 or 6 problems like what we're about to do next. Jalen, question? Okay. On the next page, you're going to do some matching again, but here you are going to use both the A value and the C value to match. So ideas about wide, narrow, up, down, and also ideas about the y-intercept. See what you can do here. A couple ways you could go about doing this, but I kind of want you to figure those out on your own. And you'll also see things like this in the homework too. Again, we should be on page 9 right now. We should be doing some matching. Just out of curiosity, how did you guys do this? What did you use first, the A value or the C value? kind of split. So some of you decided the up, down, wide, narrow stuff was the first thing you should look at. Some of you decided the y-intercept was the first thing you should look at. Personally, I kind of used the y-intercept first because I kind of thought that narrowed things down a little bit, and then I kind of decided from there. Michael, what did you say for number 1? A. And I think letter A is the only graph that has a y-intercept of -4, so it has to be that. Now, I think 2 and 3 are going to be C and D in some order, because C and D are the two that have a y-intercept of 3. Philip, how can you determine which one's which? Okay, so what should number 2 be? D. And number 3 then should be C, because they're both opening down. They both have a y-intercept of 3, but C is wider, D is narrower, so C should be the one with where the absolute value of the A value is the smaller value. We're comparing a half, we're comparing 1. The half should be the wider one. Good so far? Okay, so 4 and 5 are B and E. Who can tell me which is which? Jalen.
5 is E because it's negative.
Yep.
It goes down. And 4 is B because positive goes up.
Good. And did you notice they were both the same, like, wide narrowness? One is just up, one's down.
Yeah.
But that kind of makes sense because they have the same absolute value, the A. Okay, so really the A value is nothing different from last time, but the C value can also be used to kind of narrow our options to figure out the y-intercepts of things. Okay, next. We need to be able to find the vertex of these parabolas, because when we graph things, the vertex is kind of a pretty important point we need. There's a formula to find the vertex that I'm sure you saw in Algebra 1, but it's been a little while. But Philip thinks he remembers. You are very, very close. Aha. To find the vertex, the formula for the x-coordinate is x equals negative b over 2a. X-coordinate of the vertex, negative b over 2a. This is a very important formula. We're going to be using this quite a bit today to find the vertex, the x-coordinate of the vertex of our parabola. How would you find the y-coordinate, though, of the vertex? Let's say we figured out the x-coordinate was 4. Hans, how can we figure out a y-coordinate if we know an x-coordinate? Preston. Exactly. There's no special formula for the y-coordinate. We're just going to plug in the x-coordinate and see what the equation gives us. The y-coordinate, we are going to plug in the x-coordinates. So I'd like to do letter A with you. You'll try B on your own in a moment. I want to find the vertex of that parabola, of the parabola y equals x squared plus 6x plus 8. Well, the x-coordinate is going to be negative b over 2a. My b value is 6, so negative 6 over 2a. Over 2 times 1, negative 6 over 2, negative 3 is the x-coordinate of the vertex. I'm now going to go and I'm going to plug it in. Y is going to equal negative 3 in parentheses squared plus 6 times negative 3 plus 8. Yes, I need to see the plugging in work. That should not be a surprise. Negative 3 squared is 9. 6 times negative 3 is negative 18 plus 8. 9 minus 18, negative 9 plus 8, negative 1. The vertex is a point, so I always need it written as coordinates. We're going to say that vertex is negative 3, negative 1. Not too bad? Go do letter B. Okay, yes. Don't just give me the number, though. Show me you're doing some plugging in to get the number. Don't just jump like in A straight to negative 3. Give me some part. Negative B over 2A. Negative 3 squared is 9. 2 times 9 is 18. I think you should have this problem. 18 minus 36 plus 19. I hope. Kayla, do you have an answer?
Negative 3, 21.
Yeah, I think that will give you 1. Wow, okay. So x coordinate is not always negative 3. Y coordinate is not always like positive or negative 1. But you see how to calculate things? Questions, issues? Graphing these things. So one of the things we're going to see in this chapter is based on the form that you're given, the graphing is going to work in a very different way. If you're given a parabola in vertex form like the homework that was due today, you're going to take your parent function, you're going to move it, you're going to stretch it, you're going to flip it. If you're given a parabola in standard form, we're going to follow a different procedure for graphing these things. So we are going to look at page 11. We want to graph the parabola x squared minus 2x plus 3. What would be like a really good thing for us to know to be able to graph this? Eli. The vertex. That's going to be step number 1. We are going to find the coordinates of the vertex. Well, how would we do that? It'd be nice if there was like a formula or something. Like, what is it? Exactly. Find the coordinates of the vertex by x equals negative b over 2a and the plugging in. Take a moment. Go deal with that. Go find the coordinates of your vertex. And then stop. How about 1, 2? Next thing we're going to do, this is still probably step 1 for our process. We're going to plot that vertex, and I also want to draw in my axis of symmetry, that vertical line that goes through the vertex that kind of splits the parabola into 2 symmetric parts. I'm going to plot the vertex and draw in the axis of symmetry. So I'm going to plot 1, 2. I'm going to draw my vertical line through that vertex. I need a few more points. So we're honestly just going to make a table of values to get a couple more points. Step number 2 is going to be to make a table of values. Starting with the vertex, I'm going to make my vertex the first point in my table. And, well, to make sure I get some important points that are going to be on the graph, I'm going to start at the vertex and move right twice. Let's just copy it down. I'll show you exactly what that means in a moment. And moving right twice. I guess I should add another step in here. Then we're going to plot those points. So I'd like you to make a table, x in one column, y in the other column, and we already know the first point in the table, 1, 2. We already went through all the work to find that. We don't have to do more work to get that. Here's what I mean by the moving right twice thing. If you're at 1, 2 and move right 1 space, what x value are we at? 2. If we move right again, what x value are we at? 3. Those are the x values we're going to put in our table. If we were starting at 5, move right, you're going to get 6, and then 7. So now I need to plug in, and I do need to see the plugging in work, but to find y coordinates, we're just going to plug into our original formula. I'm going to plug in 2. I'm going to get 2 squared minus 3 times 2 plus 3. I do need to see the plugging in work. This will give us 4 minus 6 plus 3, negative 2 plus 3. I think that is, wait, hold on. What did I do wrong? Because it's not 3 times 2, it's 2 times 2. 4 minus 4 plus 3, we should get 3 there. You plug in the 3. Hopefully we can get 6 out of that. What'd I do? What'd I do wrong?
What about the simplified value you find after the next two y-intercepts instead of using the graph?
We can, however, the problem may not always be close to the y-axis, and then the y-intercept is not going to be as useful as the points that are closer to the vertex. We might miss some of the details of the problem if we automatically jump to that one. So in this case, it would have been okay. Not always will that be the most useful thing for us. Jalen.
Didn't they show our work in the y table?
No, you could do the work somewhere else, but somewhere I need to see the plugging in that gives you the 3 and the 6. Okay, I've got half of a parabola. I need the other half. Is there a quick way I can get the rest of my parabola? Hands. Duda. Yeah, that was the point of the axis of symmetry. We need to be symmetric about that line. I don't need to plug in more values. I can just take what I already have and reflect them over that axis of symmetry. This point over here at 2, 3 was 1 away to the right. I'm going to flip it so it's 1 away to the left. The point at 3, 6 was 2 to the right of the axis of symmetry. I'm going to flip it so it's 2 to the left of the axis of symmetry. Step number 3 is exactly what we just talked through. We are going to reflect those points over the axis of symmetry, and then we'll just connect the dots. Reflect the points over the axis of symmetry, and connect the dots. So I already took care of the flipping part. I'm going to connect the dots. Preston made a comment a little bit ago about the y-intercept. Looking at the original problem, what should the y-intercept have been? 0, 3. Is it actually? Yeah, that wasn't one of the points I put in my table, but I got that point by my reflection stuff. Questions so far? Turn the page. Letter A. Find the vertex and stop. Can you get 2 for the x value? Okay, so I've got negative 2 squared. Should I be writing this as negative 2 in parentheses squared? Magana, you just said no? Aha. This is not plugging in a negative number. This is plugging in 2 and doing 2 squared and then making it negative. So if you'd want parentheses, you'd put it just around the 2, but not the negative part. So what is negative 2 squared in this case? Negative 4. You see what I'm talking about? Okay, so plus 4 times 2 minus 2. This is negative 4 plus 8 minus 2. 4 minus 2. 2 comma 2? Vertex is 2 comma 2. If we were moving to the right, oh, you can't say anything. If we were moving to the right, what's the next x? Eli. Next x. I think you can handle the rest of this problem. Bless you. Take a moment. Go do your plugging in. If, when you plot them, it does not look like a parabola, you messed up somewhere either with the plugging in or with finding the vertex. So go back and see if you can catch those mistakes. That's not right. Should be positive. Is it right that this parabola should open down? How could we have known that before we even did the problem? The negative value up front. Y-intercept should be negative 2. Yeah, 0, negative 2 is showing up. Good so far? Moving on, letter B. Is this parabola going to open up or down, by the way? Up. Will it be like normal width, narrower, wider? Just say it. A little wider because of the a value of a third. Okay, I realize the a value looks horrible here, but I don't think the vertex should be too terrible. Maybe we'll do some of this together. The vertex is x equals negative b, negative 2, over 2a. Well, what's 2a? 2/3. 2 times a third is 2/3. So I need to do negative 2 divided by 2/3. This does not look good. I do not like to divide by a fraction. You probably don't either. How can I get around that problem? Shreya? Yeah, instead of dividing by a fraction, we can multiply by the reciprocal. I think that's an easier way to think about doing this. That's going to be negative 2 times the reciprocal of 2/3 is 3/2. The x is negative 6/2. Oh, that's really not too bad. That's just negative 3. We could do that as well. I think that's going to get more complicated if like the top was also a fraction. I think the better way is just multiply by the reciprocal. I think it's easier not to make mistakes if you do it that way. We're going to plug in, we're going to get the y value. We're going to do 1/3 times negative 3 in parentheses, where this time I do need that negative in the parentheses. Let's see, so I've got to do 1/3 of 9. That's not going to be terrible. Minus 6 minus 1, Katie. Okay, over here I was plugging in a negative x value. I was plugging in negative 3. In this problem, my x value I was plugging in was positive 2. It was a positive value, and the negative was part of the formula. Do you see the negative x squared over here versus the I'm plugging in negative 3 into regular x squared? Yeah. That's the difference. And I'm thinking we should be able to get negative 4. So negative 3, negative 4 is my vertex. Oops. You guys can't see that, but now you can. Oops. Are you with me so far? Okay, so now is where this could get very unpleasant. If we move right, we'd plug in what? Negative 2 and then negative 1. Here's the problem. You plug in negative 2, you're going to have to multiply that by a third. Well, okay, negative 2 squared, but still multiply that by a third. You're going to get messy fractions. Do you want to do this, or you want to like cheat and make this a little easier? Okay. Rather than plugging in negative 3, if we move to the right, what's like the next good x value I could plug in and easily multiply by a third? Nathan? 0. That won't be too bad. But I've got to move it right twice. After 0, I'd have 1. Is that nice to plug in? Multiply that by a third? Still kind of ugly. If you're moving right from 0, what's the next good number you can multiply by a third? 3. If we're using these numbers that are multiples of 3, it still counts as moving right twice, but it's going to make the plugging in so much nicer, and we're not going to have to deal with horrible, ugly fractions in the work. We're going to get a third times 0 squared plus 2 times 0 minus 1. You can totally handle that. Probably don't even need to actually go through the plugging in to know what that's going to be. And then you're going to plug in 3. Please do that. Philip? No. Absolutely. You can just kind of jump straight to that because we know it's the y-intercept. I'm fine with that. What will make this a tiny bit trickier is the flipping. It's not as easy as we're 1 away or we're 2 away. You're a little further away from the axis symmetry. I think making that a little trickier is not bad compared to plugging in messy numbers that'll give you fractions. Already looks to me like this is going to be a little wider than a normal parabola. That's a good thing. Question, Jack? Okay. So I'm getting 0, negative 1. And as Philip said, yeah, that is just the y-intercept. If you just say 0, negative 1, I'm okay with that. Then I plugged in 3. I got 8. And I'm going to do some reflections now. This point's 3 away from the axis of symmetry, so it's going to be 1, 2, 3 away on the other side. This point was 6 away from the axis of symmetry, so it's going to be 6 away. 1, 2, 3, 4, 5, 6 on the other side. I'm going to connect the dots. And I've got my parabola. When you're making your table, start at the vertex. Go right twice, usually just the next 2 numbers. But if it's a fraction a value, maybe go right to the next multiple of whatever the denominator of the fraction is, and then again. So if we had a 1/4, and I was starting at like 0, I think the next x value we should plug in would be 4, and then 8. Does that make sense? That's going to show up in the homework. You're not wrong if you plug in negative 2 and negative 1. It's just going to make the work uglier than you probably want it to be. I don't really feel like doing another graph. You guys good enough with the graphing? There are 3 graphs tonight in the homework. That's not going to be a big deal. Next thing I want to talk about is converting. Every form tells us something useful right away. Vertex form, you look at it right away, you know the vertex. Standard form, you look at it right away, we know the y-intercept. I need some way of being able to convert from one form to the other. Today we're going to look at going from vertex form to standard form. Next class after the quiz, we'll talk about standard form to vertex form, which is a little bit trickier. On the bottom of page 13, to convert a parabola from vertex form to standard form, we'll fill that in a moment. Let's take a look at letter A. I think it's very easy to look at this parabola and know what the vertex is. Do you agree with me? Cameron, what is the vertex? 4, 6. And if you think for a moment it was moved right 4, it was moved up 6. Yeah, 4, 6 for the vertex. I don't think it's as easy to look at this right away and know the y-intercept. But if I was in standard form, I could handle that. So standard form doesn't have that like parentheses square thing. It's just ax squared plus bx plus c. Any ideas what I'd have to do? Josh, what do you think? That's exactly what we're going to have to do. We're not allowed to have that piece in parentheses squared. We're going to have to, and I'm really glad you didn't just say, like, distribute the square, because we're certainly not allowed to do that. We need to write this thing out twice and do some foiling. Where it says to convert a parabola from vertex form to standard form, our process is just going to be FOIL and then distribute the a value. Well, and then doing some combining like terms, but I'm not going to bother writing that part. We're going to FOIL and distribute the a value. So in letter A, that y equals negative 3 times x minus 4 squared plus 6. That's negative 3 times x minus 4 times x minus 4 plus 6. We've done these before. You're going to take a moment. You're going to FOIL x minus 4, leave the answer in parentheses with the negative 3 out front. So in the next step, you can distribute the negative 3, and in the final step, you'll deal with the plus 6. You can handle this. Go do this. Again, make sure you're keeping that foiling inside the parentheses, because that negative 3 is going to have to get distributed to the stuff that you're foiling, and not to the 6 at the end. Oh?
The way it looks is, I thought you were saying that we had to distribute the 3 for x minus 4 and other.
No. Order of operations says do the exponents before the multiplying, do the squaring, do the foiling, then distribute the negative 3 to that foiled answer, but not also to the plus 6. I think we should get y equals negative 3x squared plus 24x minus 42. We were asked to do one more thing in this problem. We were also asked to find the vertex and the y-intercept. For the vertex, there is an easy way to do this and a not easy way to do this. How can we find the vertex? Preston. You mean like just look at the original form and pick out the vertex? Absolutely. What is the vertex? We already said that, I think. 4, 6. The not as easy way is to do negative b over 2a. There's no reason, though, to do negative b over 2a. If you have vertex form, use vertex form and just pick out the vertex right away. When we have a test on this stuff, you're going to need to know what you can get very quickly from each form. If you are foiling everything, putting it in standard form, and doing negative b over 2a, you will never finish the test. If I ask you to find the vertex of this thing, don't foil it, do negative b over 2a. Just look at it and know it's 4, 6. But I also want to find the y-intercept. Natalie, how would we go about finding the y-intercept? Yeah, that has nothing to do with the original problem from vertex form. That has everything to do with our answer in standard form. 0, negative 42 is the y-intercept. Make sense?
This is on the y-intercept. It'll always be 0.
Exactly. I would like you to do letter B. Yeah, there's a fraction, but this is like Algebra 2. We can handle multiplying by a fraction. It's not a terrible fraction. See what you can do there. And I would recommend trying to do as much of B as you can without a calculator, because no promises this will be on a calculator part of the test. You should be able to work with some small fractions. Jalen.
What was the thing you said that it took us forever to finish?
Okay. If I just give you this problem and ask you to find the vertex, if you remember that formula, negative b over 2a, so you make everything into standard form and then do negative b over 2a, you'll never finish the test. If I just give you this and say don't even convert, just give me the vertex, Just look at it and tell me 4 comma 6. Okay, I don't want you using negative b over 2a on absolutely every single problem. If there's another way to find the vertex, use that shortcut. Does that make sense?
So algebra and grade the same form we can still use.
Of course. We have both forms. Let's just use whichever one is easier to find that particular piece. While you're doing some work, deal with that later. While you're doing some work, I'm going to pass out the cumulative review. Yes. Oh, no, that was ow. Go do some work. Do next Friday, and then we'll take a week off. I just won't give you one for the short week of Thanksgiving. So right now we should be doing letter B. And when you're done, do also give me those coordinates I'm looking for. Coordinates of the vertex, coordinates of the y-intercept. No, so first of all, you lost part of the function. This is not a function the way you wrote it. This is an expression. There's something really important missing. Yeah, which is actually why you're not allowed to multiply it into you get 2y on that side rather than just y. We do have to leave it in the plus, if you did, this is a y equal we multiply by 2, it's a regular problem. We changed it to that looks good. Except that there's an issue with how you wrote it. This is not a function. You need that y equals 1. Of course you do. Yep. So I think you'll have to deal with that at the end. That was supposed to be handed in at the start of class when I asked for them. Word after words. So just a little bit of common denominator work, nothing too terrible here. We should get y equals 1/2 x squared minus 5x plus 35 halves. Vertex. I hope you didn't do negative b over 2a. Heather, what is the vertex? One more time? By 5. Y-intercept, 0, 35 halves. One thing I did notice looking at a couple of your papers, though, make sure you have the y equals part. It's not a function without the y equals, so just make sure that's included in your answer. Shreya. Oh, okay. Okay. So homework. The beginning of the homework is a little bit of review of stuff that's going to be on the quiz. More of the, here's the graph, write the formula in vertex form. The rest looks like a lot, but a lot of it is some of the matching stuff, which should go pretty quickly. You have 3 graphs, and I think 2 converting problems you're going to do. In addition to the homework, there is another homework assignment for some of you. It is written next to our stuff in green. Start bringing in the food you signed up for the food drive. I will scan in the list. I'll put it online on the website so you can check what you signed up for, but do start bringing things in on Monday. It's a short food drive. It is done next Thursday. Homework on the board in the back. And we're going to stop